day for the rest of 1.1, we need to learn about the different types of equations. If you get right there, squared in purple, if you get x equals a number, okay, that would be called a conditional equation because it's on the conditions that this is the only number that x can be. That makes it true. Right? I wouldn't get -8 if I plugged in anything else in the world. Okay, so it's a conditional that it has to be this value for it to be a true equation. We'll see one where we end up getting like 0 equals 0. And that one looks really weird, but if that happens, that quite literally means you can plug anything in and it'll end up being a true equation. It's called an identity. And then the last one that we'll see is going to be a contradiction. So you end up plugging something in and you end up getting all the way down to the end and it's like 2 equals 5. And you're like, okay, I just broke math, right? Obviously 2 does not equal 5. And so that type of equation would be called a contradiction. Okay, so then we're gonna go through there. I'm gonna write everything down and we're gonna do, I think like an example of each of them as we do it, and then we'll be able to start 1.3. Where is my note? Okay, that's why. There I got confused. I have this other piece of paper about whenever we do variables and stuff. I want to try to get done with this. It's just like a couple more rules. I really want to do this first, so yeah, I need to charge. Oh, okay. I just broke my laptop. Oh, that just happened. I don't know how to put it back there. Okay, y'all. I like literally just broke everything. If y'all want to start, we're gonna actually start writing. We're gonna do the second example, and it's going to be 5. I gotta log back in. I messed something up. 5, and then we're gonna open parentheses. And it'll be 5x plus 9. There we go. I must have touched a button. I didn't mean to. Try not to touch it again. Okay, so this is the second example. And it is 5 open 5x plus 9 close equals 13. And then we're going to subtract or do like a minus sign. And then we're going to open parentheses again. And we're going to do x plus 7. Okay, so we need to kind of work on this equation right here to see what we end up getting for our answer. The directions, like I always say, it usually just says solve. Okay, because it's not going to tell you all the different steps you need because it's not one process fits all. Every equation, you might do a different step first. And if you do, always just kind of start from the left to the right, like I say, to read it as a book. What I would notice here, the very first thing I see is that this 5 is touching the parentheses, and that's whenever we do the distribution. That arrow, I'm literally just saying I'm going to take this 5 and I'm going to multiply it to the 5x. So whenever you have your variables, if you're doing multiplication, you would like add the exponents, but what we have here is 5 times 5 is 25. The second 5 has a variable x, so we're just going to say don't forget that variable. It was a part of the multiplication, so it's going to stay a part of the answer. It doesn't go anywhere. And then, Isaac, do I just add 5 and 9 together now? The answer is no. Right? Because I'm going to actually distribute it. Okay. This is the common mistake right here is everyone will do that first step and multiply those terms. But then when they go to do the second step, they just add these together or they subtract them. Okay. Since that x and that, well, I'm sorry, that 5x and that positive 9 are inside of the parentheses, it's being multiplied each and every single time by whatever's on the outside. So if I do 5 times 9, I get 45. And then when I look at their signs, remember when I said with multiplication, if the signs are the same, then it's a positive. That 5 in the front, that's a positive. That 9 I just multiplied it to, right there tells me that's a positive. Positive times a positive is a positive, okay? And so that's where that sign goes right there. So don't accidentally tell me right then that it's like 25x plus 14. Okay, like that's like very, very first step, everything's messed up. There's no way to recover from that. Okay, you're always just kind of going to bring your equal sign down. And then I noticed that I have a 13 and then like a minus sign or a subtraction sign, whatever you want to call it. And then that's where the parentheses get opened, right? What's not here that you don't see is there's like an invisible implied 1. Okay, this is actually 13 minus like 1 open. Okay, they don't really show you that 1 though. I'm going to write it in blue. There's a 1 right there. The goal is still the same thing. If I have anything touching a parenthesis, what I do is I need to do that distribution. Here, the 5 kind of made more sense. It's an actual number, multiply everything. Over there, it's a negative and then an open. Okay, what you have to do is you have to distribute or multiply everything by this negative 1. What ends up happening is the signs change. Because we're just going to write our 13, y'all. We didn't do anything with it. Nothing's happened to it. It's out in the front. Bless you. It's just going to come down. Okay, and then this negative 1 times both of these things, just do it individually, one by one. So I know that's a 1 times a 1x, right? 1 times 1 is 1. And then don't forget that variable. That x is going to be a part of like the product or the answer. But you notice how in the parentheses that x is positive? Whenever I do that negative distribution on the inside, it's going to change it. Right? When I do this multiplication right here, I'm telling myself signs are different. When signs are different, then the answer is negative. Sorry, that's a weird looking little negative sign. Okay, and that, I'm sorry, y'all, because I was talking too much. I didn't actually do it, but I'm doing the distribution part here. Okay, and I'll do it again. Take this negative 1. Remember, you won't see that blue 1 because it's invisible, but I see a negative in the parentheses. Just actually distribute it into the next term. If I do a negative 1 times a 7, what happens there is you still have the 7, right? Because 1 times 7 is 7, but your signs change. So 1 times 7 is 7. And then I notice a negative and a positive. So signs are different. That makes the answer to that multiplication a negative. And now I know that personally, I always like to move my x's to the left. So this is where I no longer have any parentheses left. So I actually start moving things around. If there's any way that you can combine something together because it's alike, then you would do that first. On the left-hand side, do you notice how those have nothing to do with each other? One has an x, one doesn't, right? You can't math them together. You can't add them, you can't subtract them, you can't do anything. They're just going to stay that. Whenever I look on the right-hand side, I see that 13 is just a number with no letter, right? And then that 7, that negative 7 is also just a number with no letter. So what I can do is I can combine them together. You look at the signs to tell you really what to do. But if we just kind of, I know it's minute and it's tedious and it's a lot of steps, but I'm going to write down the left-hand side because now I'm actually going to combine those terms on the right-hand side. Trying to think, it really, y'all, there's like 3 different ways you could do this. Hey, you can write the negative x in the front, you can combine the numbers, or you can combine the numbers and put them in the front. It doesn't matter. Okay, the goal right here, what I'm looking at is I'm just going to kind of highlight it, y'all. This highlighting that kind of looks ugly, doesn't it? This 13 is a number with no variables. That negative 7 is a number with no variables. You can do math on them. And if you do math on them, you get a 6. 13 minus 7 is 6. So I just have my 6 right here, and then that negative x. I think what I'm used to doing, y'all, so I'll always just kind of put like a line underneath them, or I do something. You could do whatever you need to do to kind of show yourself that these are what I'm doing in this step right here, especially in case you ever get lost and you have to go back and find your way home. Okay, so what I'm going to do now is I know that I need to get all of my x's on one side, and then that way I just have the answer on the right-hand side. I think that I'm just going to grab this x on the right and I'm going to move it to the left. Whenever I do this, this is where we use the additive inverse, and I need to look at it on the right-hand side. This is where I'm moving it from. Additive inverse, inverse means what? Opposite. So do the opposite of what you see. What I see is a negative x, or like minus x. The opposite would be to add x. Doing this over there makes it go to 0. Yeah, well, 6. Yeah. No, you're right, Isaac. I can't cover up the screen because it's weird. This is going to go to 0, right? Which leaves that 6 over there, but I need this X to go away. I want this X to go to 0 on the right-hand side. The thing is, in order to keep things balanced, what you do on one side, you have to do on the other. Okay, don't mess up and accidentally put the X right here. Because then that's you telling me you're about to add those together. I can't. They're not alike, right? I need to put that plus X under whatever else has an X on it. And it's just like little itty bitty tiny like steps can be so messed up in so many different ways. And it's like, that's what makes everything hard. It's all the rules, right? So I know I wanted to move the right X over here to the left. That's why I looked at it. I did the opposite. What you do to one side, I got to do to the other. If you don't keep it balanced, everything's broken. And now that I've written that step, now I'm going to read it left to right and like work on it. Okay. So if I do 25X and then I add another X, that's like a 1X, right? 25 and 1 is going to give you 26. And if y'all wanted to kind of put a line under here, because like you're doing addition or subtraction, that's fine. Okay, just don't let it confuse you or anything. And then I do the 25 and the 1, that invisible 1, I get 26. When you add variables, you just add the variable, keep the letter that you see, and then like keep the exponents as well. So if this is X to the first power, and I'm adding these together, it's just going to stay X to the first power. That's what these rules are that I kind of didn't do first. But I don't think it gets too crazy right now. That 45, y'all, is a positive 45. I have not touched it. It is literally just going to come down. I'm gonna move my screen up. I hate how this thing stays right there. Okay, and then you have your equal sign. Some people will put a line down to kind of keep that equal sign straight all the way, and like you don't forget it or lose it, and that's fine. Right here, this 6 is in the front. Nothing's underneath it. I haven't touched it. I haven't done anything to it. I just bring it down. And then Isaac, what does negative X plus X give you? That, So that's the 0. But so you just, no, but what did you just draw? How? Tell me how. Look right here. Sorry, y'all. It's like awkward having to stay. Okay, so this 6 just came down right here where I'm looking. What happens to that? So then we could like, you could put plus 0, but it's like Y, right? Like putting plus 0 doesn't really do anything. So what you can do is you could just draw a line through them. You can, this is like a calculus thing. Draw like a little line with an arrow, like you're telling yourself, hey, that went to 0. Right, that made that fall off. I did that for a reason, right? I didn't want any X's on the right-hand side. I wanted to move them to the left. And whenever that goes to 0, I actually did that step of moving it to the other side, right? So on the right-hand side, all I have is 6. That's it, okay? Now, and I hate this answer kind of because it's like, anyways, now what I want to do is I need to get anything that is just not a phone number. Why did I think that? Anything that's just a number to the right-hand side. Okay, yes, this has a number on it, but to solve that mathematically, if it's being multiplied and I want to solve for X, I'm going to have to divide. That's, remember I told y'all, that's never like the first or second step. That's like the last step. Okay, so if I know I moved this because it was an X and I wanted it on the left-hand side, my step now, because there's no more X's over here, is going to be, I don't want any numbers, but that are just numbers over here. I want to move them over. Right, so what would I do if I do the opposite, the additive inverse? If I try to get it away from the left-hand side and move it to the right, what's the opposite of positive 45? Yep, I'm going to subtract 45. And what I do to one side, I have to do to the other. And what is that, y'all, 39? Yes. Okay. So I have that, like that's set up to do it, right? I know I need to move it. I write down what I'm to do, and then I read it like a book. 26X, literally I haven't done anything to it in this step. So I just write 26X. And then like we're very intentional when we do equations, right? Because like obviously we have to make sure that we're going to get it down to like the correct answer. So whenever I did this step right here, what I was telling myself was I wanted that 45 to go away. Y'all, if you put that in your calculator, 45 minus 45 is what? 0. It just goes away. So you can, I mean, do whatever you want to tell yourself that that's gone. And I did that for a reason. I'm glad that happened. I have my equal sign here. I combine these. Signs are different. So what you do is you subtract. and then you would keep the sign of the larger. 6 minus 45 is going to give you a negative 39. So you would just grab your calculator right there. Okay, that way you just make like a simple calculating mistake or like addition or subtraction mistake. Okay, now I've gotten to that step to where on one side I have nothing but like numbers, right? I don't have any variables on the right-hand side of the equal sign. On the left side, I've got the X, right? I know that I'm trying to solve for X, but I noticed that I don't have anything to add or subtract. The only thing remaining is the fact that it's being multiplied by something. And so what I'm going to do if I have anything really multiplying my variable and I want to solve for that variable is the opposite or inverse of multiplication, which is what? And you divide by everything that it's like multiplying it, right? Everything that's multiplying this X right now is the actual number 26. Okay, so I'm going to divide by 26. And because it's a balancing game, whatever you do to one side, you have to do the other. That purple is like, hey, this is the step I'm fixing to do, right? And then you do that step. So like set yourself up so you know what you want. And then now we do that step. Left-hand side, if I do 26 divided by 26, I get 1. Right? I did that for a reason, because if I get 1, and then what remains? 26x minus 20, I'm sorry, divided by 26 is going to just give you 1x. Right-hand side, 39 divided by 26. Remember how I just said I didn't really like how this answer was. It ends up being like a fraction. But you could grab your calculator and you could actually put that. Do I have my calculator today? If you grab your calculator, if you have the graphing one, you would do like negative 39 divided by 26. It's going to give you a decimal. My math lab doesn't want decimals. I don't want decimals. Okay, if it's through decimal, if your answer in your calculator is in decimal form, I can show you. You do math, enter, and it'll turn it into a fraction. Okay, what I'm going to tell you here though is that this could actually be divided by. What is that divided by 13? So y'all don't. I'm just going to tell you what the answer is because we can move on from this, and I'll show you to use your calculator. But I know that 13 can go into both of these numbers, and what I would end up getting is negative 3/2. And I personally would not check this equation. It just happens to be one that came from the homework. And I know it could look really ugly and it might not make any sense, but that is your correct answer. And that would be an example of a conditional equation. The only thing that makes that random equation that they showed me true is that fraction right there. Y'all, I'm gonna put right here. This is what I did. I don't want to just say it and not write it, but essentially what I did was I divided the top and the bottom by 13. In y'all's calculator, I'll just show you 39 divided by 26 and then turn it into a fraction. Okay. So hopefully we can, now let's start. Types of equations. I'll let y'all write whatever you need to. So I have that. Okay. Okay, so the first type of equation is called an identity. An equation that's an identity is always true. No matter what values are substituted. I don't know why that's hard to substitute. Answer looks like 0 equal 0. This delay is gnarly today. And the answer looks like 0 because 0 means that you're going to have an equation and you kind of start solving it. And then you notice like, okay, so all my numbers just went away. And then you notice, okay, all my variables just went away. Everything just went away. Your answer will actually literally be 0 equals 0. And if that ever happens, you would say this equation is an identity. Okay. We could also say that the solution set is all real numbers. And that kind of goes along with the first part of this definition. It says always true no matter what values are substituted. So to say that there's a solution set that can make this equation true, and then to say it's all real numbers, that's because no matter what real number you plug in, it's going to end up being true. Okay, you'll always get that answer of 0 equals 0. And then we're going to do like a little example right here. I'll write it in purple. So always true no matter what values are substituted. Answer looks like 0 equals 0. Solution set is all real numbers. Okay, and that is what we call an identity. If I need to go down because y'all didn't finish writing anything, y'all just tell me, okay? The example we're going to do is going to look like this. 3 open, x plus 1 close equals 3x plus 3. So it's like solve this equation and tell me what kind of equation it is. Like I know that there's like a handful of questions like that on the homework, right? Well, what I noticed is the very first thing that I see is that I have a 3 and it's like touching a parenthesis. So that implies, or that means, right? That tells me to distribute. So I'm literally going to take this, that little arrow means take this 3 times it by the x. Whenever I do 3 times x, I get 3x. The second step is going to be to multiply your 3 and your 1 together. Don't add, okay? Remember, we're multiplying. So if I do 3 times 1, I get just 3. These are both positive values. That 3 is a positive and that 1's positive. Positive times a positive is a positive. And then we get equals. Now we're going to do our right-hand side. About here, I'm going to do a little asterisk. If you see it, you see it. If you don't see it, it's not a big deal. But do you notice how they are the exact same thing on both sides? So if I subtract 3 from both sides, I'm going to get 3x equals 3x, right? And then I'm like, oh, I want to solve for x. And I start dividing things. Like I'm going to end up getting 0 equals 0. I'm going to solve it. But right here, it's kind of like a hint. Hey, these are exactly the same. It's going to end up giving me 0 equals 0. You don't have to actually solve it all the way. If you could say like by inspection, right? Like I can tell this is an identity. Hey, but let's say that we did kind of, actually solve it all the way. Let me see. It really doesn't matter which way you go. I like to move all my variables to the left, right? That's how I've always done it personally. So if I look at the one over here, that's a positive 3x. What's the opposite of plus 3x? And then what I do to one side, gotta do it to the other. I just kind of set it up like that. Right? Now I've kind of, my colors have switched. So now black's my steps and purple's my problem. And like I said, if you want to do a little line like this, because this is what we're doing 3x minus 3x, but that's going to end up going to what? 3x minus 3x. Do 3 minus 3. It ends up actually just being 0. Because it's going to go away completely. So because it's the exact same thing. Okay, look, y'all, if I asked you this, 13 minus 13, that's 0, right? X minus X, 0. Oh, wow. Wow, these sides 0 got all kinds of wonky. Okay, now if I did 13x minus 13x, that's also going to be 0. It's the exact same thing. The same thing as the additive inverses, right? So if you have the exact same thing with different signs, it goes to 0. 1 minus 1 is 0. A million minus a million is 0. XYZ minus XYZ is 0. Like I said, the exact same thing. So what I notice, I always forget. I think I can do this. Hee. So very, very left-hand side, right? 3x minus 3x is 0. Okay, because I did that for a reason. I did that on purpose. I'm trying to move it. Now, what sucks is usually this doesn't happen very often. Usually what happens is we have something. I'm going to write the 0 just kind of show you. And then bring down your plus 3 equals. And then what happens right here? No, you're right. I was letting her write and I was watching. And then bring that one down. And then we have, now we're here equal and then 3x minus 3x, Jackson, 0. And then what do we have next to it? Plus 3. And then, y'all, we don't even really have to do anything else right here. 0 plus 3 is, yeah, and then hold on, if I want to keep solving this, what I would do next is subtract 3 from both sides. But what am I gonna end up getting if I subtract 3 from both sides? 3 minus 3 is equal. Okay, so again, the asterisk where I said, hey, if you could see here, they're the exact same, this is gonna happen, use that shortcut. Because all of this gets confusing as hell. Because you're like, hold on, I'm not doing something right, my X has just disappeared, and you're gonna like not know, okay? Everything from like this, subtracting the 3x going down got confusing because my X's went away. Right, I'm used to there being an X and I'm used to having it like X equals a number. Okay, but there are equations where as you're solving them, your answer ends up being 0 equals 0. That's only going to happen if your X's go away. But it can get really confusing because you're not used to that happening. Okay, so if you notice some point in an equation, you do one step or whatever it may be, and you're like, these are the exact same thing. 3x plus 3 is 3x plus 3. If you go through there and solve it, you're going to get 0 equals 0. Okay, but knowing this little shortcut and being able to say this is an identity right here is way easier than confusing yourself by going through all these steps right here. Okay. Okay. I like the ones where you actually end up getting like X equals a number. I don't like the identity, so I try to do that one first. We're done talking about that one. Now let's do conditional. Got all kinds of notes right here. I want this one. Okay, conditional. Conditional quite literally means that there's conditions on what the answer is, what it can be, what it is, the only thing that makes something true. Okay, identity, 0 to 0, all real numbers, everything makes it true. Conditional is only true for some values, not all. That's what we write. It's only true for some values, comma, not all. Solution is I'm trying to see how to write this. Solution is the one value. There's a delay and I can't really see myself. Solution is one value that makes the equation true. And then the last thing we'll write right here is I'm trying to write without knowing what I'm doing. That makes equation true. Answer looks like what's happening. Okay, X equals. Oh, don't tell me whenever y'all can't see me. I'm struggling over here with this delay. So the solution is going to be whatever value it is that makes the equation true. So like, what's the solution set? It's going to either be 1 or 2 or 3/2 or 5 or 6 or 7, right? It's just going to end up looking like X equals a number. We don't know what the number is. So I'm literally just going to put number. Okay. So if you get X equals a number, that solution is only true. I'm sorry, that equation is only true for that number. The solution set is whatever that number is. Okay, and the answer looks like X equals a number. Okay, and then so we did like a little example, and what we took was just like 2 x equals 4. I told y'all to solve for x. Soleil is bad. If I told y'all to solve for x, if I look on the right-hand side, there's not multiple things over there that can add or subtract, right? It's just the number 4. If I look on the left-hand side, there's not multiple things over here either. The only thing there is 2x. Okay, so I don't have anything to move around using the additive inverses. I'm actually at the step where the only thing left to do to solve for that x, divide by 2. Right? Because it's being multiplied by a 2, so I need to divide by 2. The opposite of multiplication is division. If I divide by 2 on the left-hand side, I need to divide by 2 on the right-hand side. I already wrote it. Y'all just haven't seen it yet. I don't know why it's taking so long. On the left-hand side, if I do 2 divided by 2, right? 2x divided by 2, what I get is just x, right? Because those 2's, what ends up happening is 2 divided by 2 is 1. I did that for a reason. I only wanted there to be 1x left, right? And dividing it by 2, I now have 1x left. I've already written so many things. I don't know what's happening. I'm actually gonna keep writing since there's a delay. It makes no sense for me to wait. On the right-hand side, if you do 4 divided by 2, you get 2. And signs are the same, so it's a positive 2. Okay, so I have equals 2. So give it a second. I'm gonna talk, but what I just got was that for that little bitty small baby equation, my x equals 2, right? So if we were to go back and check, wouldn't that be if it's 2 times x, 2 times 2? What's 2 times 2? It's 4, right? So it's saying that x equals 2 is the only thing in the world that can make that equation true. Okay, that's why it's conditional. It's not anything in the world, all real numbers. It's just one specific value. Okay, x equals 2 is the only one that would make this true. Because if I plug a value in right here where you see this x, I already highlighted it. Okay, 2 times what equals 4? Only 2. Okay, it's conditional. It's conditioned on the fact that there's only one answer that makes it true. Nothing else in the world does. Okay, that's what it means for it to be a conditional equation. It has to be just one value. Now, there's a possibility that if they do ask you for like the solution set, so I'm just writing solution set. Set is shown to you with braces. So it's like a parenthesis, but they're the curly ones, right? Now, if I have one value that makes this equation true, and I just solved that it's 2, y'all, I've freaking been writing and nothing's coming up. And I've just solved that 2 is the only thing in the world that makes that true. If I wanted to show it to you in like a set notation, I would open parentheses, you put the number 2, I'm sorry, open your braces, and then close it and give it a second because I already have it written. It just hasn't shown anything yet. Okay, so that's a brace, right? And then you have the number 2 because that's the only thing in the world that makes this equation true. And then you close it with another brace. So it's just a brace facing the other way. I don't know, there's nothing I can do about this signal. Just wait. Okay. So like the solution set for the first one, we would say all real numbers, right? All of them can make the equation true, not a problem. Solution set for this type of equation is just going to be that one value, but you use curly braces, okay? And then the last thing we're going to do is a contradiction. And for an equation that's a contradiction, the only way to like really say it easily is to just say that there's no solution. The first one told me all numbers work, right? As far as the set of solutions that would mean you answered it correctly, any real number is fine. And then the first one, that was that one. The second equation we did was there's only one value, right? There's one value that is like a solution or something that means that you answered that equation right. This third one means no matter what you do, you actually cannot ever have an answer. You can never have a solution, okay? Because whenever you do start plugging things in, you start getting contradictions where it tells you that something equals something else, right? 1 equals 10, 1 does not equal 10, right? So you're like, hey, there's no solution for this equation, right? And so let me just kind of do this example. Say we have 3x minus 7 equals 3 open x minus 2. 3x minus 7 equals 3 open your parentheses x minus 2 close your parentheses. Okay, so it's like, hey, solve this and tell me what kind of equation this is, right? So if I solve this on the left-hand side, I'm going to kind of swipe up. On the left-hand side, the only thing I see is the 3x minus 7. I can't put those together, right? I can't actually do any math on that because the 3 has a variable, the 7 does not. So that left-hand side is just going to stay and look the exact same way it looks right now. On the right-hand side, I notice I have parentheses. Okay? So what I'm going to do is I'm going to actually distribute that 3 into everything inside of the parentheses. So what you could do, because it's perfectly fine too, I just go ahead and kind of rewrite my left-hand side. I couldn't do anything to it, but I know that it's going to, come down with the rest of the problem. On the right-hand side, I'm going to do the distribution, which is multiplication. 3, I'm getting mad with this delay. 3 times x is going to give you 3x. And then I'm going to let that pull up first. So this is me doing distribution. 3 times x is going to actually give you 3x because they just multiply together. And then with the other part of the distribution, it's going to end up being the 3 times the 2. 3 times 2 is 6. Signs are different. So it's a positive 6 or a negative 6. It'd be a negative, right? Negative times a positive is a negative. And so I end up having 3x negative 6 or 3x minus 6 on the right-hand side. I really don't even know what to do. So aggravated right now. We're just sitting and waiting. Okay. Now trying to solve for my x. This could also kind of be a shortcut. Before, for the one that ends up working out with any solution at all in the world, you plug into it, right? The all real numbers, that shortcut or like that place that you could stop if you see it was when both sides were exactly the same, right? This almost looks exactly the same. If I end up moving my x's, right, I'm going to end up subtracting 3x from both sides, and then I'm going to end up getting 0. Do you see what I mean? Like my x values went away, right? So if we're going to solve this all the way, but this is also one place where you could be like, this almost looks exactly the same on the left and on the right. I start moving things around, my x's are going to go away. I'm going to end up getting something that is going to be a contradiction. Let's go and do it. So I don't have anything that can be combined on either side. What I need to do is actually start moving things, right? I want all of my x's on the left. So what I'm going to do is I'm going to do the opposite of what's going on over here on the right. So I wrote negative 3x on the right-hand side underneath the 3x. And then what I do to one side, I have to do to the other. So I just wrote negative 3x underneath the first term in the equation right here. Watch me get on the board. That'd be annoying. We're gonna have to wait. I literally want that to pull up so y'all can see what the heck I'm doing. Oh, after this, we need to solve like a little formula. It's like really abstract. It seemed like a lot of notes. These are all repeats. Okay, so on the right-hand side, I'm subtracting the 3x because I want to put all of my variables on one side. Like that's always like the first thing I think of. And so on the right-hand side, I'm like, oh, what's the opposite, right? What's the additive inverse? What do you use to make things go to 0? Right? I'm going to use the exact same term, but I changed the sign. Opposite of positive 3x is negative 3x. What you do to one side, do to the other. And I've actually worked on this. 3x minus 3x, it goes away and gives you 0, right? So I'm actually just going to draw a line through it. Okay? After a while, like that just makes more sense. than writing 0. There's no reason to write 0 ever. Now this -7, I have not done anything to it. So I'm actually waiting for my purple. Okay, I'm gonna just write -7. And then I write my equal sign. And then now I'm here on the right-hand side of the equal sign. The first thing I see is with that term 3x, I've subtracted itself, right? 3x minus 3x is no x's. It goes to 0. No reason to write it. Now, if there's still a delay, y'all, it has not caught up at all. But I'm going to draw my little blue line through it, right? Hey, this went away. I did that for a reason. I was trying to move it. What I end up seeing here, though, is, hey, this is a special kind of equation because my freaking x's disappeared. Usually they never do. If they do, you're in 1.1 and they're asking you what kind of equation this is. It's the only time you'll ever see that, okay? Now, after I've done this subtraction, all I have left is the -6. I'm just gonna go ahead and bring it down. We are gonna have to wait for this to catch up to us. But I want y'all to see what ended up just happening there. In, I don't know, 3 hours. Meh. That looks funny. I just saw that. It says meeting. I have a meeting from 2 to 4 today. It says DEA. It's diversity, something else, equity and access, but it looks like Drug Enforcement Agency. Sorry, I see a squirrel. Just get distracted. So that -6 on the end just comes down, right? I didn't do anything with it. But then you notice right here that you end up getting like -7 equals -6. You know, if you want to keep on going, you can. I really don't think that, I mean, you end up going down a rabbit hole. You could eventually get to something equals like 0. But right here, can y'all at least tell, I just went up or see that it's telling me 2 values that are not equal are equal, right? Like it's basically lying to me and it's saying -6 equals -7. I know for a fact -6 does not equal -7. So this would be a special type of an equation that does not have a solution. What it's saying is, one, you can't ever actually answer it because there's not one X value that would make this true. And there's not all the numbers in the world that would make this true. It's saying no matter what you try to do, you're going to get a contradiction. Okay, so this is a special type of equation I've already pulled up one time ago that we're going to end up calling a contradiction because there's no solution set. Nothing makes it true. And then let me show you how they could end up writing. I'm writing solution set. Specifically in math, if you have an equation or something that doesn't have a solution, it's said to have an empty solution, right? So the first one we did, it was 0 equals 0. Okay, that's not empty. That's all real numbers that exist in the world can make that equation true. It's like it's special type of equation, right? The second one, there wasn't all the numbers in the world. It was whatever one number is. It's conditional. You got one number that can make this equation true. With the contradiction, how did it not have a solution set yet? There's not a single thing in the world that you could put in here and it be a true solution to this equation. So it's called an empty set, right? Because there's no solutions. I'm going to write it, y'all, but there's 2 different ways that you could put it down as an answer. And it's going to either be open brace, immediately close, put nothing in it. Up above on the second example, we put the number 2 in it, right? Because 2 is the only thing that made that true. This one, there's nothing that make it true. So you open your brace, close your brace, leave it empty on the inside of the braces because that's telling me that's an empty set. There is no solution. Nothing makes this true. Or you could do where you have a circle and then you like draw a line through it like a slash. There's like a circle with a slash through it. That's also a symbol for no solution or like an empty solution set. Nothing makes this equation true. Okay. I'm gonna let that load. I've got one more type one more type of problem that I know you'll see on 1.1, and then we're going to just kind of start talking about 1.3 as much as we can. I really can't do much if it's not even going to like show y'all what I write. I think I might end up being on the board. If I am, I'm taking my shoes off. Oy. Oh, yeah. Maybe that's what it's been trying to do, and that's why it's so, like, it's like lagging. I keep doing this, I'm gonna sound like my kids when Fortnite starts lagging. Just gonna be screaming and yelling at somebody and everybody. Let me see, maybe I did that. Let's see if it kind of is caught up in a way. But do you see how I opened the brace and then I closed it, right? This is me telling you, hey, this is the solution. There ain't nothing in the solution, right? So it's literally saying there is no solution, which means that special type of equation I was dealing with would say, some kind of contradiction at the end. No matter what value I plug in, I'm gonna end up getting the wrong answer in a way because nothing can make it true. Okay, let's just see. No, sorry, I cannot be that. Like at all, man. I need some allergy pills. Okay, so it's his very last one for 1.1, and then we're gonna look at 1.3 for like 15 minutes, 15, 20 minutes. Okay, yep, no, they're still to play. Isaac, will you help me? I think we're literally gonna have to like move this. I hate being on the board. We're gonna actually move this whole entire screen over there, and that way I could just write and talk and not have to wait on technology. We need to make sure